Good morning, everyone. Today we are going to solve the daily lead code challenge of 19th January 2024, and the question number is 931. The name is minimum falling path sum. Let's read the question statement. The question statement says given n into n array of integer matrix, return the minimum sum of any falling path through matrix. Any falling path through matrix. Okay, what is a falling path? The falling path starts at any element in the first row. That means this row, any element in this row. From position row comma column will be row plus 1 column minus 1. Acha. Okay, row plus 1 column. Okay, so from the falling path starts from any position in this first row, and it goes, for example, if we are starting from this position, it can go either this way, either this way, either this way. And if we are choosing this position, then it can go this way and this way. Following, this can go here and here, but this one can only go this side and down one side. And we have to return the minimum sum of the elements which fall in the path of the falling path. Okay, so this clearly looks like a recursion question, and we should use memoization as well to reduce the time complexity. So yeah, let's jump to the question. So what first off we'll write first off, let's imagine what are we going to do. So let's imagine we are at position I comma j. So we can either go to I plus 1 comma j minus 1. That means here, if we can, we will go, and if we can go I plus 1 comma j, that means from here to here, just downwards, or I plus 1 comma j plus 1. So that means we have to write a function in which we can do these three operations, and then we have to return the minimum of these three. Return you and minimum of these three. The minimum is going to be returned here. So let's jump to the code. First off, we have to write a recursion function. Let's name the function path sum, or minimum path sum, that would be better. Minimum path sum, and the arguments we are going to be needing is I, j, and the matrix itself. So arguments are going to be I, comma j, comma mat. Let's call the matrix mat. So yeah, first thing we need to have is an end case. If I equals to length mat minus 1, that means if I is in the last row, this row, the last row, then we can't go any further. We can't go down any further. So we just have to return the value of that current box or current cell. So we'll just return the value of that current row, current box, current cell, whatever. Then first we have to declare three variables, one for this, one for this, and one for this. So a equals to, so we have to calculate the minimum of these three, right? So we should initialize the variables with infinity. B equals to infinity and c equals to infinity. Okay, now for the first case, for this case, so we can't perform this case for every case. For example, if we are at a position like this one, so we can't go any further this side, right? That means we can't perform this operation. We can only perform these two. So we have to check before performing this operation that either that we are not at this position, we should not be at this position. So that's what we have to check. If j is greater than 0, that means j is not this at, at the corner, j is before the corner. So if this satisfies, then we can perform this. A is equals to function, this minimum sum I plus 1 j minus 1 comma mat, right? And next one is going to be if I think we don't need any. We can perform this operation for every conditions, right? Only for this, only if we are not at the last row. So we have already checked that we are not in the last row. If we have been in the last row, we have already returned the value of the current cell. So we are not at the last row. So we don't need to check for this one. B equals to B equals to this, and the value of j is going to be same because we're not moving sideways, we are only moving downwards. And c is equals to, we also have to check for this operation, right? So if j is less than minus 1, that means j is somewhere here. J is somewhere here, not here, not at the corner, not at the right corner. It should be somewhere else. So that's what we're checking here. So if j is less than mat of, then we are going to be doing c equals to, and j is, we're just going to add this. Yeah. Now what should we return? We have to return the minimum of these three, A, B, C. We have to return the minimum. plus we also have to add the current cell's value. So we will be returning, let's call it x equals to, or answer equals to, minimum of a comma b comma c plus mat I j. Yeah, so the thing we should be returning here is the minimum of these three plus the current value. That should we return it here. We have returned it now. I think we're done here. So let's call it done. Hold on for a second. So at the first row we can start from any of the first rows, right? It's not that we have to start from any particular row. So we have to do it like this. First we have to call a for loop. Let's declare a variable answer equals to infinity. Okay, and for I in range, I'm sorry, for j in range, should be for j in range, len mat 0, yeah, answer equals to minimum of answer comma this. Yeah, so the j's value is going to vary. Yeah, and then we should return the answer. Yeah, let's run this. Oh, it says mat is not defined. Okay, so just do this. Now the mat is defined. I is not defined. Okay, instead of I will be sending 0. Yeah, at the first position, at first row, the value of I should be 0. Unsupported operation type. Okay, so it's returning. So this is unsupported. Yeah. Oh, get it. I get it. Totally get it. Should be like this. Yeah. Syntax error. So as you can see that these two test cases are running properly at least. So we should try submitting it, and I'm sure that we'll be getting a time limit exceeded error because the time complexity is in something and to the 2 to 3 to the power n, so that's like quite high, 100. So yeah, time limit exceeded, but we have test case 38. We have reached test case 38. After that, time limit has been exceeded. So what should we do now? Now we should use dynamic programming. We should add a memo, and we should use memoization. We'll be returning an empty dictionary. No, not an empty dictionary. We should declare the memo here. Memo is a dictionary which is going to be storing the values of outputs for all the particular queries to this function. A memo needs to be declared in all the function declarations. Function, wherever we are calling the function, memo needs to be declared. Memo here, memo here. Now what should we do? So first off, how should we store the values in memo? So we are going to be using tuple as the key, like this. Memo of tuple of I comma j. This is going to be unique for every query. I comma j, that's going to be equals to answer. And if we have already calculated the minimum output for ij query, then then that means if I comma j is if I comma j is already in memo, then what should we do? Should simply return memo of I comma j, and that should reduce the time complexity drastically. Now let's try to run it. I think will run. Yeah, it's running, and I think we should be able to submit it now. Bullseye. We have a submission. Successful submission here. Thanks for watching. I'll be posting every day I'm posting the solution for the daily LeetCode challenge, so you can subscribe to this channel if you are a daily LeetCode solver. Okay, thank you.